different types of sets. Let's start with the first thing. The first one is empty set. What is an empty set? A set which does not contain any element is called an empty set. So if I talk about, let's say, natural number, okay, let me write it this way. If I say there is a set A such that, what's the condition? X such that x should belong to natural number and x should have the value less than 1. Now we know that natural number starts from 1, so there is no natural number which is less than 1. So this case, the element does not have any element in it, it does not contain any element, then I would say A is an empty set. What is an empty set? A set which does not contain any element. And how do we denote it? We denote it by this, either this symbol, this is called phi, or I can use the empty curly brackets, empty braces. Both of this denote an empty set. And we also call empty set as null set or void set, different names for the same set. Next is finite set. A set having finite number of elements is called a finite set. If I say, let's suppose we have a set B. Set B is collection of elements such that it is natural number and it has to be less than 10. Then how many elements would it have? It would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means how many elements now have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We already know this set B has 9 elements and it is a finite number. So if a set has a finite number of elements, then I would call it as a finite set. So in this case, B is a finite set. Now if there is any set which is not finite, then we can call it as infinite set. What are some examples of infinite set? Natural numbers, integers, real numbers, rational numbers, all of these are infinite set. Why? Because the number of elements present in these sets are infinite. Fourth number of set is singleton set. What is a singleton set? A set which is having only a single element in it is called a singleton set. For example, if I want to say, let's suppose here we would change this into this set. Now the set is x such that x belongs to natural number and x has a value less than 2. What are the natural numbers less than 2? The answer is only one number possible. So A is equal to 1. How many elements does it have? Single element. So A is here singleton set. And finally we have fifth number. But before going there, let's try to see something. Here if I want to see, what have we seen? That the first set is empty set. Empty set means no elements. Second is finite set. Finite set means the number of elements have to be finite in number. Infinite means there are infinite elements in it, and singleton means single. So now there are some number of elements present in that element, in the sets, and we call those number of elements to be cardinal number. So now what is a cardinal number? The number of elements in a set is called the cardinal number of a set. The number of the number of elements in a set means whatever the number of elements are there. Now we have a particular word for that, which is cardinal number. So if I have a set A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then how many elements does it have? 10 elements. So I can say the cardinal number of set A is 10. And how do I denote it? I denote it by n of A. N of A is equal to 10. So if we talk about empty set, what would be the empty set's cardinal number? As we can see, a set which does not contain any element is empty set. So if there is a set which does not have anything, the cardinal should be 0. So the cardinal number for empty set would be 0. For finite set, let's suppose there is a set A with n elements. Then what would be the cardinal number for this particular finite set? N. Or to not have any confusions, let's say A has k elements. Then what would be n of k? N of A would be k. What about infinite sets? Infinite set has infinite elements. So the cardinal number should be also infinity. What about singleton set? In singleton set we know the set has only one element. So if there is any set A which is a singleton set, I would say that n of A is equal to 1. This was the differentiation or categorization of sets on the basis of number of elements. But what if now we have two sets? For example, there are two sets A and B, and we have some comparison on the basis of number of elements in set A and set B. So what are different categorization we can do in this? Let's try to understand that. The first set here that we are supposed to do is equal sets. What are equal sets? Two sets A and B are said to be equal if they contain exactly the same element. Let us just repeat once. There are two sets A and B. And when can I say these sets are equal sets? If they contain exactly the same elements. That means, let's say our set A is x such that x belongs to the natural numbers and the condition is 1 less than x less than 5. What would be the set A? Set A would be 2, 3, 4. Now set B is equal to, let's say, x such that x belongs to positive integers and 1 less than x less than 5. Then here, what are positive integers? We know integers are the set of numbers which contain 0, positive numbers as well as negative numbers. So this is integers, but we are only interested in what? Z plus, that means 1, 2, 3 and so on. So out of this set, I have to take a set which contains element from this and the value of those elements should be between 1 to 5. So what would B look like? B would look like 2, 3, 4. Now if I compare set A and if I compare set A with B, then if I can see the elements in A is 2, 3, 4 and elements in B is also 2, 3, 4. So can I say the elements are equal in both the sets? Yes, we can. Then I can say set A is equal to B. This is how we can represent, or this is how we can write equal sets. If let's suppose there were one more set. Let's suppose if I have any more set which also gives you this same answer 2, 3 and 4, then what can I write? I can write A is equal to B is equal to C. These are called equal sets. Now what if the number of elements are same but the elements are not same? What would we call such elements? We will call such elements as equivalent set. What do we mean by equivalent set? Let's try to understand it. Let's see what are equivalent set. Equivalent set. If they have same cardinal number. Let's suppose there are two sets A and B. Set A is all the numbers such that it belongs to n and x is less than 5. And B is a set which contains x is first 5 or sorry my bad first 4 English alphabets. What would set A look like? 1, 2, 3, 4. What would set B look like? A, B, C, D. Now if I see how many elements are there? 1, 2, 3, 4. So the cardinal number of set A is 4. What about set B? There are 4 elements in set B as well. So cardinal number of set B is also 4. So if I get the cardinal number of set A and set B to be equal, I can call such sets equivalent set. And how do I represent it? I represent it in this way. So I can write symbolically this to represent A and B as equivalent sets. These are symbols to you to represent equivalent set. Now I'll ask you a single question. What if I have this A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4. Here you can see that the elements are also same, so you would say that yes, A and B are equal sets. But can I also say the number of elements are also same? That is, the number of elements in set A is equal to number of elements in set B as well. Yes, we can say that. So now what can I say? That all the equal sets are also equivalent sets. But the reverse of it is not true. The vice versa statement is not true. All equal sets are equivalent sets, but all equivalent sets are not equal sets. What have we learned? Equal set means all the elements are same. Equivalent set means the cardinal number is same. The number of elements are same, but the elements might be different. Now, next set is disjoint set. What do we mean by disjoint set? Disjoint set means there is no element in common. So if I have two sets A and B, then set A is, let's suppose, first 5 natural numbers, then this is a weight roster form to represent set A. And if I say B is the first 5 alphabets of English language, then A, B, C, D, E. Here I can see 5 elements, here also 5 elements, but anything is in common? No. Then I call such set as disjoint sets. If there is everything in common, then it is equal sets. If there is nothing in common, then it is called disjoint sets. And if only the number of elements are common or the number of elements are same, then it would be called equivalent sets. Now, there has to be some sets. For example, 1, 2, 3, 4, 5. And let's say there is one more set. 1, 2, 3 up till 10. So first 5 natural numbers is set A. First 10 natural numbers is set B. What would we call such sets? Can we call it equal set? No. Can we call it equivalent set? No. Can we call it disjoint set? We can see here that there are some elements are in common, right? 1, 2, 3, 4, 5 is present in A as well as B. So these are not disjoint as well. What would we call such sets? Let's try to understand that. Subsets. What are subsets? Let A and B be any two sets. Then A is called a subset of B if every element of A is also an element of B. What does it mean? We have two sets and we can call A is a subset of B. If I want to say A is a subset of B, then what should I do? I have to show that every element of A is also an element of B. So here if I see A is 1, 2, 3, 4, 5. So I can say that this 5 elements belongs to A. Are they also belonging to set B? Yes, I can say that this 5, and there are some more elements as well, but this 5 also belongs to set B. So every element which is present in set A is also present in set B. Yes, if this is the condition and it is satisfied, then I can call A is a subset of B. And how do I denote it? I denote it by this notation. A is a subset of B. What does it mean when I say A is a subset of B? I mean that every element which belongs to set A is also belonging to set B. This is subset. A is a subset of B. And the reverse statement, the reverse order or the vice versa statement is B is a superset of A. So if A is a subset of B, then I can say B is a superset of A. I hope this definition was clear. If we have a clear idea of subset, we can move on to proper subset. What is the difference between subset and proper subset? Let's try to see that. When I say A is a subset of B, I mean that every element of A is also an element of B. But now, if I want to see when can I say A is a proper subset of B? If I want to say A is a proper subset of B, then what is the condition that has to be followed? Let's try to see that. Let A be any set and B be non-empty set. Then A is called proper subset of B if every element member of A is also a member of B. Same condition as subset, that every element of set A should also be a member of set B. But in addition to that, there has to be at least one element in B which is not a member of A. That means that there has to be at least one. Minimum one element should be in B which is not present in A. That means what? That the number of elements in A should always be less than the number of elements in B. If there are some common elements, it's okay. But the number of elements in set B will be higher. There will be at least one element in B which is not in A. If this is the case, then it is a proper subset. For example, if I write A is equal to 1, 2, 3 and B is equal to 1, 2, 3 as well. And I'll take one more, 1, 2, 3, 4 and 5. Then if we take a look here, I can say every element of A is also an element of B. So I can say A is a subset of B. I can also say B is a subset of A because every element of B is also present in A. Now, if we take A and C, then what can I say? Every element of A is present in C. Yes, that is true. But in addition to that, the number of elements, sorry, I meant C, not here. B, I meant C. The number of elements in C is higher than the number of elements in A. If these two conditions are satisfied together, then I could call A is a proper subset of A. What can I say? How do I represent it? I represent it by this. This is proper subset. And same goes for set B as well. That if I see the set B is subset of C, but also the number of elements in B is less than number of elements in C, then B is also a proper subset of C. What is the difference here? For subset, if elements are equal, it is okay. If they are not equal, then also it's okay. But for proper subset, the number of elements in the set are always not equal. Here it's 1, 2 and 3, so 3 elements, and here it's 1, 2, 3, 4, 5, so 5 elements. We have 2 elements which are not in A. So we got more than 1. At least 1 means minimum 1 should be there. If there are more than 1, well and good. So this is the difference between subset and proper subset. And now finally we will talk about universal set. What is a universal set? A non-empty set of which all the sets under consideration are subsets is called a universal set. What does it mean? It means that, let's suppose I am taking the sets which only contains the letters A, B, C, B is equal to C, D, F, and so on. There are many sets. Then here all the elements are what? All the elements are alphabets. Then in this case, what would be the universal case? The universal set could be the set which contains all the alphabets. Why? Because according to the definition, a non-empty subset of which all the sets under consideration are subsets. That means I have this A to Z. Now I can take any set from here and it would be a subset of universal set. So if I am talking about, let's suppose, a class, and there I am asking each of the students to make a set out of their name. That is, for example, let's say there is a guy named Rahul. Then if there is a guy named Rahul present in the class, and if I ask him to make a set out of his name, then what would it be? R-A-H-U-L. Similarly, each of the students would make such sets. And in that case, what would be the universal set? Universal set would be a set which contains all the alphabets. So if I am talking about a situation where all the elements are alphabets, then a set which contains all the alphabets is a universal set. If I am talking about roll numbers of the students in a class, let's suppose the class has 50 students. So each of the student would have a set with their own roll number. That means each of the students would have a singleton set. Which element would be in those sets? Whatever the roll number a student has. And if I ask the universal set in that context, then what could be the universal set? I have, let's suppose, 50 students, and I am asking them to make a set of each of them individually according to their roll number. Then I would have 50 singleton set. Then if I take a set which contains all the numbers from 1 to 50, then that set could be my universal set. Yes, it could be, because all the subsets are now inside the universal set, and I denote it by capital U. This is what we use to denote universal set. So this was universal set. We'll quickly revise what we did. We have seen what are empty set, finite set, infinite set, and singleton set on the number of elements in a set. Now when we have more than one set, 2 or more than 2, then what are the categorization? Equal sets. Equal set means all the elements are equal. Equivalent set. Equivalent set means the number of elements, the cardinal number, is same. And disjoint sets. That means nothing is common in the set. If I have 2 or more, then there is nothing common in between them. Then their sets are disjoint sets. Subset means we have 2 sets, and if there is a set A which has some element which are also present in set B, then I could call such set as subset. A subset B, B superset A. And if I add one more condition to it, that is A is subset of B, but number of element in A is smaller than number of element in B, then it would be called a proper subset. And finally, universal set. whatever we are talking about, whatever the sets are made up of. If there is a set which contains all the elements, all the subsets in the consideration, right? If I am talking about set which are made up of alphabets, then there is a set which contains all the alphabets, then that is the universal set. A non-empty set which contains all the subsets into the consideration, that is universal set.